Let's start with a topic that is extremely important in any programming language. This is about methods. To address this topic, we'll create a new project. So we go to File, New Project. We select the Visual C# tab. We choose a console application with the Net framework. We're going to name it Methods Demo. We click on OK. Here we have the application ready to start working on. We'll position ourselves inside the main method. This main is a method, which is what we're discussing right now. You'll understand in detail what's going on with the definition we have here. So far we've done some exercises. If you remember, with console.writeLine, we've written some text or carried out some operations inside console.writeLine. Because of this, we can define, or we can see that when we use a method, we're utilizing functionality that someone else wrote for us to use as part of our applications. This WriteLine method isn't the only one available within the console class. Don't worry about the term class right now. Just remember that console has more than just this WriteLine. If we start typing console again, we see that at the bottom there are 3 buttons that allow us to filter some characteristics of the console class. Among them, we have the properties that we will look at later, the events that we will also review later, and we have this button that allows us to filter the methods that are part of the console class. We'll press this button that allows us to filter methods. It has a cube-like symbol indicating that these methods are the functionality or the tasks we can perform as part of this console class. Let's examine what the different methods are, or at least some of them. We see that we have some methods, for example, to carry out the printing of text through WriteLine that we have used previously, but we also have some interesting methods, such as this one that says set cursor position. Let's click on it to use it. And if we open the parentheses, we see that here it asks us for a number to tell us where we want to position the cursor, both to the left and up. We're going to put a couple of parameters, for example 10, 10. The term parameter refers to the values that this left and this top will occupy. Later we will see this in more detail. We are going to copy this line from above and paste it again so that you can see what happens after executing this set cursor position function. We are going to write console.writeLine. Remember that the application does not wait until we press a key. We will run the application. Okay? Notice what's happening. Here we are printing at the position 0, 0 hectare, and later when we execute this set cursor position method, we are positioning ourselves at the position 10, 10. This is why this second text of hectare appears all the way down here. It means that we are using a console functionality to position ourselves in a different position. We can carry out other actions as part of the console. Let's see what else we have available. We carry out the filter, and we will also see a method called setWindowSize, which the translation would be set a size of the window. That is, we can modify the size of the console window. Let's see what parameter it asks us for. It asks us for a width and a height. So we're going to give it a width and a height. We are going to specify that we want the window size to be 50 by 50. We are going to proceed to run the application. We see that it marks an error here, indicating that the value must be less than the current maximum size of 43. This has to do with the resolution of your screen. We're going to slightly reduce this size, for example to 1020. We run the application again. Notice how the window size has changed compared to the initial version we had. Here we have a smaller window, and we have done this through code. We didn't need to modify this size by clicking on this cursor to change the window size. Because this functionality is already programmed within this setWindowSize method, we can also, for example, if we wanted to make a console, and we see that we have here a method called clear, which in Spanish means to delete. So we are going to use this method. If you notice this method does not accept any parameters, it means that you can use it as is and there is no problem. We're going to change the window size to 2020 so it's a bit bigger, and what we're going to do is place a console.readLine before the console.clear so it looks better. We press the start button, okay? We see how the window size has changed. Here we have hectare and hectare. Here we find ourselves on this readline line because Visual Studio is waiting for us to press a key. Let's see what happens when we press the key. Okay, we see the screen gets cleared. That is, all the text we had before gets erased. This is because the clear method function, if you look down here, it tells us it clears the console buffer, and that's basically the action it's performing, clearing all the text we have in this window. Let's check out the last method that is part of the console, which is the VIP method, that basically allows us to launch a sound through the speaker. Let's see how it looks like. Here the text of Hector and Hector displays. We press, and at these moments you should be hearing the VIP. All in all, each of these methods allows us to carry out a different action. In this case, we modify the size of the window. This allows us to print a text in the console. In this case, we can position the cursor in a different place. Here we erase the text in the console, we launch a sound, we wait to read something from the user. As I have told you before, the important thing here is to notice that someone else wrote this, someone on the Microsoft team. We as users can also write our own methods to create additional functionality, and that is what we are going to do in the next video. Alright, let's start to see how we can create our own methods or add the functionality we want to an application. We'll begin by deleting all of this text we have here. Let's write a console.writeLine. We will write some text inside the console.writeLine, for example, hello world. We're going to write a console.readLine at the end so that the application waits for us to press a key. I assume that we want a functionality that once we type a text, we can perform some steps. Firstly, we wait for the user to press a key to proceed. Secondly, we clear the console. Thirdly, we issue a VIP sound to notify the user that the console has been cleared. We'll proceed to write this code as I have told you. So first, we want the user to press the key to proceed. As you recall, we did this with console.readLine. We then wanted to erase everything from the console. We did this through the clear method. Finally, we wanted to issue a sound. We achieved this through console.beep. So in this case, we write the word and carry out the deletion with these three steps. We will proceed to write another text through console.writeLine, and we will write, for example, a sum as we have done in a previous module. Assume that we want to repeat the same steps because we need to do it every time we have finished writing a text. So we have to write console.readLine, then console.clear, and finally console.beep. If you start to notice, here we already have some code repetition. Here, we're writing the same lines over and over. This can take up some time as you have to keep writing these 3 lines of code because it's the action you want to carry out each time you write a console.writeLine. So, what's the issue? The first problem is that I suppose you write a console.writeLine and, for example, you write some text. I suppose you enter some text, I suppose you write console.readLine to wait for the user to press a key, and I suppose you write console.beep. You might notice a problem here. We've forgotten to write this console.clearLine. So here, the console won't be cleared. Let's run the application to see what happens. We enter hello world, we enter 7, we enter Hector, but the console is not cleared when we press a key. So this is the type of problems you can have if you're continually writing the same code like in this case. You could tell me the easiest thing to do is to copy and paste this code we have here. But truth be told, look how much code we have simply to output 3 texts in the console. We have quite a lot of text. In total, there are 32 lines of code only to write 3 pieces of text on the console. Ideally here, we should use a method or create one to hold this functionality and not have to write it over and over again, but rather write the method and call that method only. To make it more clear, I'm going to proceed to write what I'm telling you. To accomplish writing this method, we are going to position ourselves outside of the main method, but within this program class. So if you position yourself next to the key that is inside the main and look at the bottom, you can see where it ends because Visual Studio highlights it in gray for you. We are going to position ourselves after this key, but within this other key that has to do with the program class. Okay, so pay attention to where this key begins and ends before you start to write the next method. The formula to write a method is given by the data type to be returned plus the method name plus the parameters. Let's see this in action. We are going to write a method to carry out the console cleaning. So, firstly, it is indicated that we need to write a type of data to return. Don't worry about this concept for now, we'll look at it a little later. But at this moment, to fill in this gap that we have here, we are going to write the word void, which means empty precisely. That is to say, our method will not return any data. Afterwards, we have to write the name of the method. This name can be any name that you want. In my case, I'm going to call it clear console. Keep in mind that the name of the method represents an action. In this case, I'm naming it clear console. This indicates that I want to carry out the text deletion in the console. If you look at the methods we have used previously, they are described in the same way: write a line, clear, make a beep, write a line, etc. So, whenever you write a method, the recommended thing is for this method's name to exemplify an action or to imply that it is an action, and also to be a descriptive name so that whoever uses it knows what this method refers to. Subsequently, we need to use a list of parameters. Right now, we'll see what these parameters are about. For now, we'll write a pair of parentheses, and in the same way, after those parentheses, we'll write an opening and closing bracket. This is the simplest definition of a method. As you can see, we already have a correct program, as Visual Studio doesn't mark any issues. We indicate that we're not returning any data, and that the method is named borrar consola. What I'm going to do next is, within this method called borrar consola, I'm going to copy this code that represents users key reading, console text removal, and the VIP sound. So I'll take these 3 lines of code, I'm going to cut this code, and I'm going to paste it as part of my borrar consola method. Here I'm creating a method that will perform these actions: read from the console by the user, clear the console, and make the VIP sound. I'll return to my original code and I'll remove these lines that repeated the text or actions again and again. Now, if we wanted to carry out the use of this borrar consola method, we would not have to use console, for example, since console is a different class in which we are. If we wanted to make use of this borrar consola method, we would have to directly invoke the method, as the method is defined within the same class we are in, so we don't need to call another class to invoke these methods. Let's proceed then to invoke the borrar consola method after the console.writeLine. But if you look, we have an error here. And basically, this error comes because in console applications, if you remember, we have this static identifier that represents a static method. We will see this static thing later, but for now, all you need to know is that if you come across a console application and you are going to declare methods within the same program class, then you also have to place the word static before the method definition. Okay, with this, as you can see, we have a correct console deletion declaration. This name that we have here, or the invocation, must correspond to the name of your method definition. If, for example, you place delete console with a lowercase c, Visual Studio will detect that this method does not exist. And here it is, the delete console method does not exist, since the correct method is delete console with an uppercase C. In the same way, if you notice, we have the invocation here through parentheses and the semicolon, as we have done many times before, through the writeLine method. If you notice, delete console is very similar to readLine since it does not accept any parameters. You can recognize that we are invoking a method because we use these parentheses and a semicolon. It's the easiest way to identify the use of a method. So I am interested in making it clear that here we are invoking a method and the method is defined here at the bottom. Let's proceed to run the application to see what happens. We see that Hello World is being printed. If you notice, it's not printing the 7 nor Hector, because it's waiting for me to press a key. Let's press the key, OK, and if you noticed, the deletion of the text took place, the beep sound was made. And here we have printed 7 and Hector, which are these two lines that do not yet have the call to delete console. You may be wondering, what exactly is happening when we are running this application? We'll explore this in detail in the next video. As part of Visual Studio, there is an indispensable tool that you need to learn to use from the start. This is referred to as debugging tools. The concept of debugging will be useful for us to evaluate what is happening in our application while it is running. If at any point you want to know what's happening in your application precisely at a given moment, you can make use of what is referred to as a breakpoint. A breakpoint is placed on the line you want to debug. That is the point where you want your application to stop to perform a detailed analysis of what's happening in your application. In my case, I want to understand what's happening right from the start. Therefore, I will position myself on line number 13, where I have the console.writeLine Hello World. I will place myself on the gray line on the left and click exactly on line 13. If you notice, a red circle appeared and the entire line turned red. Don't be scared, it does not mean there is an error or anything similar. Quite the contrary, we are indicating that the program is going to stop exactly at this line of code to perform an accurate analysis of what's happening in the application. We will proceed to run the application. You can observe that Visual Studio stopped exactly at the console.writeLine line. This yellow arrow is indicating that we are positioned or that our application is located exactly on this line. On the menu part, if you notice, some additional buttons have appeared that we didn't have before, and they will serve to carry out an analysis of what's happening in the application. We will proceed to press this button that says Step Into, which is useful for carrying out a meticulous line-by-line analysis of what's happening in the application. So we press this button, and if you notice, the yellow arrow moved to the next line. Does this mean that the application has already executed this Hello World line? If we go back to the console, we see that indeed Hello World appears here. However, at this moment it's on this console clearing line. Let's press this Step Into button again. And if you notice, it has taken us to the method called console clearing, which means that when we invoke console clearing, we are really going to execute these 3 lines of code we have here. Let's see if this is true. We give Step Into again. We see that it stops at console.readLine. We click again, and if you notice, it returns us to the console and has not put a yellow arrow because the application is waiting for us to do something to be able to act, in this case, press a key. Immediately after pressing the key, if you notice, we return to Visual Studio, and it is indicating that this console.readLine line has finished executing. Therefore, we move on to the next line, which is console.clear. We go back to the console, we have the text here. Let's see what happens if we press the button, and if you notice, if we return to the console, we see that nothing appears. This is because the console.clear line was executed. We return to the button, the beep sound execution takes place, and we press the button again, and we see that it returns us to the main method. If we continue pressing the button, we see that it launches or takes us back or continues to the next line, which carries out the printing of 2 plus 5. We press the button again and we see that it prints the number 7. We move on again to the next line of console.writeLine Hector, and we see that here we have Hector's name printed, so the execution of this application has been carried out. Let's click on the green button that says Continue to proceed with the application execution. And this is how the final application looks. This means that each time we call the console clear method, these 3 lines of code will be executed, eliminating the need to retype these lines over and over in the main application. So let's proceed to copy this text. Over and over, after we finish printing with a console.writeLine, we will disable the breakpoint by clicking the red circle, allowing normal execution of the application. Let's click on Start. Here we have Hello World. We enact the console clear function repeatedly. This is how we've built an application that allows us to clear the console every time we write something as part of it. Thus, we've defined a method that enables us to perform this action without continually repeating these 3 lines in the main program. This has saved us a good deal of code lines. To carry out this action, we will return to our formula that we have here, and we will make use of the third section called the parameters. Parameters are used to pass information to our methods and work with that information within the same method. If you look at the previous examples, here we have a console.writeLine, where we pass a parameter which is a string. In this example of console.writeLine, we pass a numeric parameter. Remember, here the operation of 5 plus 2 is carried out, which results in an integer printout. These data that we pass as part of this method are the parameters or the information that we send to the method for it to work with. In this case, we are interested in passing a name as part of the greet method to be able to display it in this console.writeLine. If you want to declare a parameter as part of your method, it must go within the parentheses that we have here available, and to declare a parameter, you need the data type you are going to use followed by the name of the parameter, which can be whatever you wish. In my case, as I want to print the name Hello and John, for example, I will use a string data type. So, we define the parameter as a data string type and then the name of the parameter, which can be any name you wish. I will name it name, for example. Now that we have defined this parameter here, let's leave a space and note that we can now use the name parameter. As you can see here, it informs me that this is a parameter that is an autostring type and is called name. This means that the parameters that you define as part of your method can be used within the method where you define them. So, knowing that we can use the parameter named name, which is basically a temporary variable, we will change hello. Add a plus sign, which, if you remember, is used to concatenate strings, and specify that I want to concatenate hello, a space, and the value of name. As this is a parameter, it can take the value that you provide through the method. So, we are going to proceed, for example, to test our greet method. If you notice, Visual Studio is already marking it here with a problem, indicating that I am not passing the parameter called name. If you observe, here we have the definition. It's indicating that you must necessarily use the sending of a parameter, which is a type of data string. That's why it's marking this line in red to indicate that I am not passing the parameter this method is expecting. Whenever you have a parameter or multiple parameters defined here, the compiler will expect you to pass those parameters as part of the method invocation. In this case, if I try to pass a 3, for example, an error occurs because it states that an integer cannot be converted to a string. This means that you cannot send any data type you wish, but the type of data specified as part of the parameter. In this case, it is a string data type, so I am going to pass Hector, for example. We're going to set a breakpoint at the greet method to see what is happening in the application. We start the application. The application pauses. We click on the button that says Step Into. We see how we jump to the greet method, click on Step Into again, print hello plus, and if we hover over the name variable, we see that the value of the name is equal to Hector. This means we are passing the value of this string to this parameter. Therefore, we can use this string, which in this case is Hector, as part of this console.writeLine. So, we proceed to run the application. Click on Continue. Here we see that we are displaying Hello Hector. We stop the application. Here, even though we've already fixed or enhanced the function of this method, we still have an issue, the fact that we're still inputting a specific string which we cannot modify in runtime. Let's change this behavior, and let's now use console.readLine, now expecting a text input from the user. Remember, the greet method expects a string data type, so I will proceed to define a variable that is a string data type. For instance, bear in mind that the name of this variable can be whatever you want, I'm going to name it name to be identifiable. This will be equal to console.readline. We place the parentheses and the semicolon, and what this console.readline will do is wait for the user to input some text string to assign it to the name variable. This would be equivalent to having, for instance, any name here like Juan. But instead of being a fixed string, we are indicating that we want the user to write this string so that this name variable can be dynamic. Thus, instead of passing the greet this string of text, we'll pass the name variable that will contain the result of what the user writes in the console. Such that we'll obtain the string that the user writes in the console, we'll call the greet method passing what the user wrote, and we'll eventually write in the console.writeline hello, plus what the user wrote. Let's see if this is correct. We click on Start. Here the application has stopped because it's awaiting for us to enter some text. We're going to write some text, and you'll see how the application is printing hello and the name or the text that we passed through writing in the console. So this is how we are making our application increasingly robust, extending the functionality of the methods we have available, learning about the parameters we see here, and using the same parameter as part of the method's functionality, in this case, to greet. Continuing with the topic of methods, suppose you have a requirement, and the requirement is that you carry out the sum of two numbers and possibly print the result. To carry out this action, we will comment out these two lines that we have up here, and we are going to proceed to declare a new method called sumar. We are going to write the static method. We are going to write void sumar as we have done to this moment. Here the first important piece of data is that we can declare more than one parameter as part of this method. So we will write int number 1 because we want to carry out the sum of two integers, for example. We will write a comma, and we are going to write int number 2. We write the brackets, and here you see that we have the declaration of two parameters. In this case, one is called number 1, and the second parameter is called number 2. You can have as many parameters as you want, as long as they are separated by a comma. Once we have this, we are going to proceed to carry out console.writeline, number 1 plus number 2, the semicolon. What this is going to do is carry out the sum of number 1 inch plus number 2 inches, and finally we are going to carry out the printing through a console.writeline. We are going to call this method before the console.readline to see what is printed, so we invoke sumar. We pass two parameters. In this case they are of integer value type. We write, for example, 10, 1, 12. You see, these two parameters correspond to the two parameters of the method's definition and have to be the same data type that you declared as part of the parameters. Finally, like in the declaration, these parameters that we are sending are separated by a comma. So here we are sending 10, which is going to be this number 1 inch, and this 12, that is going to be this number 2. If you notice, there is a one-to-one correspondence. The first data found corresponds to the first parameter we have here, and the second data found corresponds to the second parameter we have here. If we wanted to send a third parameter, we notice that the method will return an error because it indicates that there is no definition of a third parameter called number 3, for example. That's why it's marking an error here. These three data I'm sending do not correspond with the two data this method is actually expecting. Let's erase this third number. Let's proceed to run the application to see what is displayed, and we see that we have the printout of the number 22 here. Everything works well. Now suppose that as part of your company's requirement or your teacher's request, you are told that you must carry out the division of the sum's result by 2, that is, the result of number 1 plus number 2 divided by 2. But that operation you must perform before the console.readline, as you want to execute console.writeline of the division result from the main program or from this main method. Honestly, as we have it, this is impossible, since there is no way to get the result of number 1 plus number 2, because if you agree with me, we are only performing the printout of this operation, and that is where the functionality of the sum of number 1 plus number 2 ends. This is where this part of the formula that says type of data to return comes into play. Remember, up until now we have used void, void, and void, indicating that this method won't return any data as part of this method's definition. That is, I'm going to execute this method here and there its functionality ends. It returns nothing, and that ends the execution of that method. What I want to do then is return number 1 plus number 2. What I'm going to proceed to do then is remove this console.writeLine, and I will leave only the definition of number 1 plus number 2, which is really what I want to return. If we position ourselves over number 1 plus number 2, we notice that it marks an error here, because it is indicating that we are not assigning this value to anything. For that, we have a keyword that will allow us to carry out the return of information as part of this method definition. This keyword is the word return, which in Spanish means to return. So the idea is that this method returns us through this return the sum of number 1 plus number 2. However, it is marking an error in red here, and it is indicating that we are trying to return a value, in this case integer, because the definition of the parameters are integers, and yet the method is specified as not going to return anything through this void. To solve this, we have to indicate that we want to return an integer in this case, which is the result of number 1 plus number 2, it's an integer. We will then carry out the substitution of this void for the type of data that we want to return, which in this case is int. Okay, recapping, we indicate that the method will return an integer, and through this return, we are returning that integer data. If we remove this return from here, we see how Visual Studio marks an error, and it is indicating that we are not returning anything. Therefore, the return word must be reintroduced to return the result of number 1 plus number 2. Okay, we have the method ready and we are returning the sum of number 1 plus number 2. Here in the main program, we see that there is no issue with this sum method. There is no problem since the use of the data that the method returns is optional. Therefore, we can use it or not. In our case, we want to retrieve the result of the sum of number 1 plus number 2, so we're going to declare a new variable called result that will be an int type data, and it will be equal to the sum execution. We will pass the same numbers we passed earlier. As you can see, we are making the same call we made earlier, with the difference that we are declaring a variable, which will have the result of adding 10 plus 12. This will be equivalent to having the final value of 22, as we are carrying out the sum of number 10 plus number 12 here. We are going to remove this add line and we are going to make a console.writeLine. If you remember, the requirement was to carry out the division of the sum result by 2. So we indicate result divided by 2. Let's see what happens in the application. We're going to put a breakpoint on this result. Let's run the application. We can see that the application stops at this method call. We click on step into. We can see how we jump to the add method. We do one more step into, and we can see how the sum of 10 plus 12 is performed. And we are returning this sum of 10 plus 12 value. We click on step into. We click again. If we position over the result, we can see that we have the value 22, which is the result of the invocation of this add method of 10 plus 12. Finally, we carry out the operation of division results over 2. We return to the app and see that we are successfully printing the number 11. This is how we can carry the return of information from one method to another place to work with that information within our application. I say this because you could use, for example, this add method from some of the methods we've previously defined. For example, in this greeting method, we could call the add method 22, 22, and if you look, there's no problem. What would happen here is that if we invoked the greeting method, the add method would be invoked again, an operation would be carried out, and finally, the console.writeLine or some other method would be printed. I strongly recommend that you study this topic until you fully understand the concepts, as we will use this topic of methods a lot in the following modules. The C# language has been evolving over time. A testament to this is the new way in which we can declare a method. This type of declaration is called methods with expression bodies or expression-bodied methods. What we have to remember about this type of declaration is that they only work with methods that perform simple tasks. That is, they only execute one line. To see these types of declarations, we're going to scroll down to the section where we have different methods defined, and we're going to create a new method. If you remember the classic way we have seen so far, the traditional method declares the return type of the method, possibly the declaration of the method name, and within it specifies, in this case, for example, a console.writeLine. We're going to write hello Hector again. This method meets the condition I just mentioned. It only executes a single action. So, to create a method with an expression body, we just have to remove these braces that we have here and change them to an equal sign and a greater than sign. If you notice, Visual Studio is not displaying any errors now. Let's remove these unnecessary spaces to make everything more readable. And notice that we are declaring this method in a single line. There are no differences in terms of functionality. The only thing is that we're saving these extra braces, and we can see at a glance what the action is that is being carried out as part of this method. Let's declare another method so you can keep practicing. So we're going to declare it static, specify the return type, in this case int, and we'll call it, for instance, add. We can also pass parameters as part of this method. We'll name the first parameter number 1 inch and the second one number 2. Unlike the syntax of such a method, if you remember here, what we were doing was returning the sum of number 1 and number 2. Here in this case, it is marking an error because this method already exists. Let's name it sum2 to avoid any issues. Let's proceed to do the same as we did before. That is, remove the braces, place the equal sign, followed by a greater than sign. Now, if you look here, we have a problem. Visual Studio is marking an error. This is because in the declaration syntax of these methods, this return keyword is extra. If we remove it, you see how Visual Studio stops marking errors. Consequently, when using this type of syntax or declaration, the return can be omitted. Because in this type of declaration, Visual Studio assumes that the sum will be the value we are returning, since we are specifying here that we are returning a value. If we change this to a void, it promptly marks an error. The error is indicated because we are performing an action, but we are not returning anything. This implies that when you have any action as part of this method declaration, you have to return this type of data. Since it is a single line that is executed, if an operation is carried out, you have to return here the expected data type, which in this case is an integer. As I mentioned, it doesn't have any difference from the declaration of a traditional method, but here we can see at a glance two methods and their actions, or the declaration of these methods. Once the Visual Studio installer has started, we'll click on this button that says More and then click on the Modify option. Once we're in that section, we'll click on Individual Components. In this section, we have one that says .NET. We'll select the .NET Framework Compatibility Pack in its most recent version, which is 4, 7.2. Similarly, we'll select the .NET Framework SDK 4, 7.2. Once both are selected, we'll click on Modify. We'll wait a few minutes for the installation to complete. After installing those components, we'll click on Start to launch Visual Studio Community 2017. We'll proceed to open the project we created a moment ago. If we check the target platform and expand the components, we can see that we already have .NET Framework 4, 7.2, which is the most recent version at this time available. We'll select it. We will need to reopen the project for these changes to take effect. We'll click on the Yes button. Now our project is utilizing .NET Framework 4, 7.2. We'll close this window related to the project's properties. Now let's move on to the topic. We need to examine a new concept. This concept is called a tuple. A tuple is a data structure that allows us to store different values of different types that are related in some way, all within a single variable. We'll start by defining a method. If you remember, we defined methods with static and, for example, returned an integer data type. We'll name this method returnData. As we have defined this method, we can only return one piece of data, for instance, an 8. If we want to return more than one piece of data, that is, an 8 and a 3 for example, we need to modify this method so that it has a different structure. In this case, inside parentheses, we are going to indicate that we want to return more than one type of data. If you notice, if we put only one element, it indicates that the tuple must contain at least two elements. Therefore, we are going to define that we also want to return another data that in this case is an integer. Unlike the previous method, here we indicate that we want to return two integer numbers, and here, if you notice, it is already showing me an error because it is saying that we cannot convert a single int data into two integer data. Therefore, if we want to return two data, we will have to encapsulate the data between parentheses in the same way, place a comma to identify that we want another data, and place the next piece of data we want to return. If you notice, there is a one-to-one correlation. And here, in this case, we indicate that this 8 is going to be the evolution of this integer data and this 3 of this int data. We can combine different data. For example, here we could indicate that we want to return an integer and a string. Here it is already showing me an error because 3 is not a string, and I could then indicate that I want to return the string Hector. This is how we can return different data from a single method. We are going to proceed to clarify a method that carries out a more complex operation, in this case a division. Then we define static, and we are going to indicate that in the case of this method, which is going to be called divide, we want to return the quotient and the residue. We have already seen how to return both data in previous videos. So, we are going to indicate that we want to return two integers. The first one will be to return the quotient of a division, and the second one to return the remainder. So, we name it divide and indicate that we want to pass two variables or two parameters, both of them being integer data types. We are going to define a pair of variables here. The first one will be called quotient, and it will be equal to the division of number 1 by number 2. Next, we define the following variable called remainder, which will be equal to number 1. Remember that if we use this percentage symbol, we are indicating that we want to return the remainder. So, we carry out the remainder between number 1 and number 2, and finally, we return the quotient first followed by the remainder. Now, how can we call this method in such a way that we can retrieve both the quotient and the remainder? There are two ways to do it. We're returning to our main method to retrieve or try to salvage this information we have as part of the evolution of our divide method. The first way is by defining two variables from the method in which we want to call the divide method. In this case, we're naming our variable quotient, which will be equal to 0, and we're defining another variable called remainder, which will be equal to 0 as well. Next, we call the divide method and pass the two parameters that the divide method is expecting, which in this case are number 1 and number 2. For example, let the first data be 50 and the second be 25. We will proceed to store the result of this divide method. To do this, we must use a tuple, which in this case we will indicate to be equal to quotient and remainder. This will be equal to the outcome of dividing 50 by 25. Here we're using a tuple where we're passing the quotient and remainder variable in a way that if later I want to print any of these data, we're going to print the quota, for example, and then with a console. Right line, we will print the remainder. We're going to execute a console.readLine to make it wait for us to enter some value, close the window, and then click Start. If you notice, the console is displaying 2, which is the value of the quotient, and 0, which is the value of the remainder. This means that we're recovering the values returned by this divide method. Let's see the second way to carry out this retrieval of information. Therefore, we can pass directly from the declaration of int quotient and the declaration of int remainder. We're going to name this variable data, which will be equal to divide, and we're going to pass it two parameters, in this case 105. If you notice, the difference here is that we're declaring the quotient and remainder variables immediately within the tuple, unlike above where we declared these two variables beforehand. Similarly here, we need to specify the name of this tuple, which in this case is data. If you notice, we did not have to specify any variable name earlier, but here, since we're declaring the variables within this tuple at once, we need to give it a name. Here we get the results of dividing without any problem, and to access this information in this second form, we're going to call writeLine. We need to invoke the variable data point. And as you can see here, we have the two variables, which in this case are quotient and receipt. First, we're going to print the quotient, and then we're going to write a console writeLine for data point receipt. We're going to proceed to execute the application, and we see that we're printing the 2 and the 0 again, but with this second form that we have defined here. This is how we can declare tuples in this way, and we can retrieve the values that we are returning as part of a method that returns more than one value. If you've noticed, up to this point, we've been declaring different variables in different methods. For example, here we've declared a variable within the main method, and down below in the divide method, we've declared another variable. If you've noticed, both variables are even called the same, but they do not affect each other. This has to do with a term called the scope of a variable or the range of a variable. This term refers to the region of the program where the variable can be used. This scope is usually specified by these brackets we have defined here. If you notice here, as part of the divide method, we have these brackets that envelop the use of these variables, in this case quotient and remainder. This means that the scope or the place where this variable will live is strictly within the divide method we have here. If we declare here a third variable, for example, the result is equal to 3, and we try to use this variable called the result in another method, in this case, the main method, notice how Visual Studio gives me an error because it's indicating that this result variable doesn't exist. Here, Visual Studio is indicating the scope of the variable as a context. So what this means is that this result or this result variable will only live within the divide method that is being encapsulated through these brackets. It's the easiest way to identify the scope of a variable. Let's then remove this error that we have here. What we're doing here, declaring a variable within one of the methods, is called a scope or a local range. Another point to note is that we can't use a variable before it's been declared. For example, if I wanted to use the result variable here, which is equal to 5, we see how it gives me an error. It's indicating that we can't use the local result variable before declaring it. That's why it's causing me this conflict. However, if I try to do exactly this after the statement, we no longer have a problem. Here, the resultado variable has already been declared, so this is a point to keep in mind. Now, you may be wondering what would happen if I want to use a variable and maintain its values through different methods. Well, for that we would have to slightly increase the scope of that variable, that is, declare that variable within another container, which in this case is the class. If you notice, the program class encompasses the two methods we have here, which in this case are main and dividir. These are the methods where we are doing tests, but we can also define variables inside this program class. Here we can, for example, declare a variable, a string type variable named nombre that will be equal to Hector. Visual Studio does not mark any error, and this variable that we have at the class level is really named campo or field. In this way, inside the main method, we could use this variable. Through console.writeLine, we are going to call the nombre variable. However, if you notice here, we have a problem as if this variable did not exist. The truth is that we cannot use it directly, as we have the same problem with the declaration of the methods. If you remember, to use the methods we had to specify the word static here, as we are in a console application. Therefore, we are going to put this static before the declaration of the variable, and if we return to the main method, we see that we can indeed print this variable, which in this case is equal to Hector. Let's verify that this is accurate. We can see that we indeed have the name Hector printed here. Let's conduct some tests with this field we have here, called name. To do that, we will create a new method, as we have done so far, static. We're going to set it as a type of void data, and this method will be called greet. We won't receive any parameters, and we'll indicate that the execution of this method will be equal to a console.writeLine, and we will pass it the variable name. If you look, there are no issues with the method declaration, and this name variable is the one we have defined at the class level. We didn't need to pass the parameter from the greet method and see how we are combining different things that we have been learning so far. Let's then change the console.writeLine declaration to the invocation of the greet method. Let's start the application. We can see how Hector's print is successful. To make this more interesting, after we greet the first name, Hector, will indicate that the name will be equal to, for example, 1. Afterward, we call the greet method again to see what is printed. Let's run the application. And we can see how first we printed the name Hector, then we modified the name variable, and finally we printed Juan. Let's do a final test. We're going to change this method definition to a definition that contains brackets. Let's organize the code a bit, and within the greet method what I'm going to do is modify this Juan name to see what happens. I'm going to remove this greeting line, and then what we should do is, upon reaching this greeting method, instead of printing Hector's name, we're first going to modify the variable name, which as you can see is in another method, in this case greeting, and we're finally going to proceed to print the variable name. Okay, we see that we are indeed printing Juan instead of printing Hector's name. This evidently means that we have this variable name available at the class level. This implies that all the methods that are part of, in this case the program class, will be able to use these fields or variables defined at the class level. There is another concept that is very important to understand about methods, and this is operator overloading. Up until now, if you've noticed, we've been using console.writeLine with different types of data as parameters. If you pay attention, we have not had problems whether we pass an integer type variable or another type of variable, such as, for example, a string. If you're a bit curious, you might ask, how is this possible? The truth is, this is possible, since as part of the definition of console methods, we have many definitions of the writeLine method, which accept different parameters as part of the method's definition or signature. If we right-click on writeLine and click where it says View Definition, the metadata file of the console class opens. Here we have the console class specified, and below are the definitions of the various methods. In this case, we are interested in the writeLine methods. Here we have each definition of the writeLine method. If you notice, we have more than 10 definitions of the writeLine method, each executing different code. Here we have the definition for when we accept a float data type, for when we accept an integer type, when we accept a string, which in this case is the method we have also been using, when we accept a character, when we accept a boolean value, etc. What's being done here with the console methods is called operator overloading. Let's look at this from a practical perspective, returning to our program.cs file. Suppose now that one of the requirements you have is to define a method called multiply that accepts two integer values. So let's go to our method definition and declare a method called multiply that returns an integer. We will accept two parameters, number 1 and number 2. Here we simply carry out the return of number 1 by number 2, and we have defined our method called multiply. If at this moment we wanted to make a copy of this method and wanted to define two additional parameters, one called 2 and another called number 3, we see how Visual Studio is marking an error here. If we position ourselves over the method, it says that the program type already defines a member called multiply with the same parameter types. This means that C# does not accept the definition of two methods that have the same signature. By signature, we refer to how the method is defined. We see here that we are returning an integer data type and the method name is multiply. The signature has to do with the parameters we have defined here. If we made a name change, we would have no problem. However, if in any case we wanted to reuse the name, as in the case of console.writeLine, then giving the method a different name would not solve our problem. If we would like to change, for instance, this return data type from an integer to, for example, a float, we see that the method keeps marking an error. This means that changing the return type does not change the method definition signature. If we wanted to keep the same name definition for both methods, we would have to change some of the data types of the parameters that form this method. In this case, if we change, for instance, this integer to a float, we see how the error is corrected. Because we have a different signature for both methods. In the first case, we have the definition of two integer parameters, and in the second case, we have the definition of a float type of data and an integer type of data. In this case, we are already using operator overloading. This is called overloading, where we have the same method defined, but with more than one method definition, in this case multiply. If we get back to our main method, we're going to pose over the read line. We're going to call it as it is the multiply method. We put the parentheses and we can see that Visual Studio indicates that we have two definitions of this method. The first one of them accepts a float type of data and the second one an integer type of data. If we switch to the next definition, we see that we return the integer type of data and we have two integer parameters here. Here we can enter some number like 2 and another 2. In the case of console.writeLine, if we write console.writeLine and open the parentheses, we see that we have 19 definitions for this console.writeLine method. We'll create another method for you to continue practicing this concept of operator overloading. Assume that we are implementing a software for a restaurant and we have to define a method called calculateBill, which will receive the total of a bill or the total consumption of the diners. We will also receive as a parameter how much money we want to add as a tip, and finally the number of diners to carry out the division of the bill among the number of diners. So we'll define a new method and we'll call this method calculateBill. The return type will be a double, so we indicate that we accept first a double parameter, which is total bill. We indicate that we accept a second parameter, which is tip, in case we want to leave a tip, and finally an integer data with the number of diners or the clients who consumed this bill. Here, I'm going to do a simple operation. I'll indicate that I want to return the total bill plus tip divided by the number of diners. So we're going to add the total bill plus the tip amount, and we're going to divide this figure by the number of customers that consumed this bill. It's a very simple operation, but it's going to help us understand this concept a bit more. Let's suppose now that we want to add functionality for restaurants that have parking, and this parking has an additional cost. So, if you notice, we have already defined this, but our method does not accept parking data. We could define a new method here, having the exact same signature, accepting a double data type called total bill, another double called tip, and finally the number of diners. We could carry out the same operation, but now we have the problem that we've defined two methods with the same parameters. So, to solve this issue, we'll add a new variable or parameter called parking. What we're going to do here is to add the parking costs to the total of the bill and the tip. With this, we've now solved this problem for calculating the bill with and without parking. We could then go back to our main method. We're going to comment out the code we have previously to see what this method displays, and we're going to indicate that we want to call the calculateBill method. If you noticed, we've defined two methods, one that does not accept the parking parameter and the second one that does accept the parking parameter. So let's say, for example, the bill was 100. We want to leave a 10 peso tip split between 3 patrons, and that's it. To display the result of this method, we're going to encapsulate it within our console, the write line, and within the parentheses, we will include this method invocation. Here, the various calculations will be made, and as we're returning this operation, it will display as part of console write line. Now let's proceed to perform this same invocation. But on this occasion, after the number 3, which is the number of patrons, we will put a comma. And if you notice, Visual Studio suggests that we want to use the second definition containing the parking variable. We will then pass the value of the parking, for example, 50 pesos. Let's proceed to execute the application to see what results it returns. We see that in the first case, it returns 36.66 as the result, meaning each patron will have to contribute 36.66 pesos. In the second case, each patron would have to contribute 53.33 pesos. This is because each of these methods performs different logic. In the first case, parking is not taken into account, and in the second case, it is. So, in this way, we can define different methods that carry different logic and with different parameters. As part of defining methods in Visual C#, we can also execute nested methods. What does this mean? It means we can put methods within other methods. Let's revisit one of the examples we used earlier, where we printed some text and then proceeded to clear that text from the console. But this time, we're going to add this functionality to perform the console cleanup from another method. This means that we're going to define a method called writeText that returns nothing. We will pass a parameter called text. Within this method, we'll create a guideline to print the text. If you remember, in one of the previous videos we performed console cleanup using 3 different methods. The first was readline, the second was clear, and the third was beep. So, let's declare a new method within this writeText method. How do we do this? There's no need to use static here considering we're within another method. Just define the return type, which in this case is void. We'll name this new method clean. Within this clean method, which as you can see is not throwing any errors in Visual Studio, we're going to define console.readline, console.clear, and finally console.beep. Once this method is defined, we'll call it after this console.writeLine. In this way, we can clean up the console once the text has been written. First, we'll see the result of executing this method, then later we'll discuss when it's appropriate to use this approach we've defined here. So we're going to proceed by commenting on these 2 lines of text, and we are going to call the writeText method, passing a string, for example Jorge. We are going to run the application to see what is displayed. We see that we're printing Jorge. We're going to press a key again. We see the console clears and the VIP sound is activated. Now, what are the advantages of using this form we see here? The first advantage is that we're encapsulating a functionality we don't want any other method to see. If you noticed before, these methods we were defining here, we had them available from our main method or from any other method that was part of class program. However, the definition of this clear method as it is encapsulated within the writeText method, it's not visible to the other methods. So if I wanted to use this method, from here I could not do it. Here it marks an error and tells me that this method does not exist in the current context. What it means then is that this method wouldn't be available from other methods, so we're encapsulating the functionality to avoid any issues in case we only want to use this piece of code from this writeText method. This is how we can nest methods within other methods. We are now going to look at a couple of extra options in parameter definition, which have been added over time in C#. The first one is called optional parameters. We will remove this cleaning definition or this cleaning call so that we don't have any issues. If you remember, in a previous video, we declared two different methods performing very similar functionality. You can see the main difference lies in the second definition involving a variable called parking, which may or may not exist for this execution of this return. What I mean is that if you notice, the definition or the execution of the code that we have within the method is very similar, with the sole difference being this variable called parking. Suppose we wanted to have a single definition of the calculate account method, but take into account or not this parking parameter, we can do it through optional parameters. As its name implies, an optional parameter can be invoked or not when the method is invoked. How is an optional parameter defined? Well, we're going to proceed to comment on this calculate account code and add this new parameter. To the first method's definition, calculate account. So far, it appears there are no issues. To define an optional parameter, we need to assign a value to the parameter that we were talking about, in this case, parking. Since this parking value may or may not exist, we're going to indicate that the value will be equal to 0. Later, when we carry out the sum of the total bill plus tip, we're going to suggest we want to add parking. We're going to return to our main method. Let's comment on this line of text and call on the calculation count function. If you notice, there's a single definition of this calculate count method, and it's indicated here by these brackets that this parameter is optional, and by default it has a value of 0. We're going to call this method passing the parameters it requests, such as 100 for tip, for example 10, and we'll state that the number of diners equals 2. Notice how we don't have any issues even though we define 4 parameters here and are invoking the method with only 3 parameters. This is because this parking parameter is optional. If we pass another parameter, for example a value of 10, you'll see we also don't encounter any problem, and in this case the value of the parking parameter will be 10. While if we remove this value of 10, the value of the parking variable will be 0. As that's the default value we have specified. This helps significantly reduce the number of methods we have in our code. It specifies that some of them have optional parameters, while others have obligatory parameters. One important point to remember is that the declaration of these optional parameters needs to come after the obligatory parameters. The obligatory parameters are those that you have to pass a value to. If I remove this value of 2, we see that calculate counts turns red, and that's because it indicates that this value of diners is obligatory. So if I try to set total counts equal to a value, say 3, we see it highlights certain parameters in red and indicates that optional parameters should appear after all the necessary parameters. This means that the optional parameters, which you'll recognize by an equal assignment, must be defined after the obligatory parameters, which in this case are these first 3 parameters. One last concept that we must take into account is the concept of named arguments. This will serve us to be able to pass parameters in a different order. This concept goes hand in hand with the concept from the previous video, which is optional parameters. Let's assume that as part of the bill calculation definition, we have a new parameter that is also optional. This would be a double data type which we'll call, for instance, VAT, a tax. Let's suppose that this optional parameter will have an initial value of 15 and that we're going to add it to the operation we had previously. Suppose we want to modify the value of this VAT parameter but without touching the parking value. We're going to go back to calculating the bill, put in the comma, and see how it obligatorily asks us for the parking value here. I would like to leave it as it is, but Visual Studio won't let me because it's indicating that if I want to reach this VAT parameter, I have to put here a mandatory value. If you notice, if I put a value and a comma, it already allows me to work with the VAT value. If I didn't want to modify this parking value, we have the option to use named arguments. This concept of named arguments refers to the fact that I can call a parameter by its name and specify the name. skipping the other parameters. So I'm going to go back here in my code, and after the call of diners, I'm going to indicate that I want to invoke the VAT variable. If you notice here, it recognizes it as a parameter, and through a colon, I'm going to specify what the new value is. In this case, I'm going to put, for example, 20. Here then, we are passing three mandatory parameters, 110 and 2. We're skipping the optional parameter, which is parking, and we're indicating that we want to modify the value of the VAT field or the VAT parameter with a new value. This is quite useful if at a given time we have a large amount of optional parameters as part of the calculate account method, and it saves us a lot of trouble. We can also do that with mandatory parameters. For example, here I could indicate that I want to define tip with a value of 20. I can indicate that I want to call the total account parameter with a value 100, and finally the diners parameter with a value of 2. Notice how we don't have any problems, even though we are calling the different values in a different order than how they are defined. Obviously, the best use that can be given to them is, as I mentioned earlier, in conjunction with the optional parameters. That's how we can use named arguments to call in different order the different parameters of a method. Finally, to conclude this part about methods, we will see a couple of tips that we can utilize with Visual Studio and the methods. Firstly, I assume you're coding your program in Visual Studio, and you know you will need a method called, for example, calculate square area, and this method will require some values, for example, 20, a string called Juan, a decimal value, for example, 50, a boolean value equal to true. I made up this data for the sake of example. If you notice here, Visual Studio obviously indicates that this method doesn't exist in the current context, meaning we haven't defined it as part of our application. However, Visual Studio is smart enough to know what types of data we're passing, and therefore Visual Studio could help us create this method. If we position ourselves below this non-existing method and click on this warning icon that appears here, we see that it indicates we have an option to generate this undefined method. Let's click on this option and see how Visual Studio automatically creates a signature for this method. In this case, calculate square area. If you notice, the parameters correspond, or rather the data type corresponds to what we've defined. Firstly, we have an integer variable. In the second case, we have a string variable. In the third case, we have a decimal type variable. And in the last case, a boolean type variable. So what we need to do here is to only define the action within the calculate square area method. Similarly, if we want to assign an integer variable called, for example, result, which equals to calculate square area with the same parameters. Notice how here Visual Studio indicates that this method does not exist, since in the case of the first method, we are returning a type of data void, while here we want to return a result to a variable called resultado, which is of integer type. Let's remove the definition of this method so that Visual Studio can help us create this method again. We position ourselves over the method, click on the focus again, click to generate the method, and see how this time it has changed the return data type from void to int. However, Visual Studio can help us create methods easily, or if you're in your code and know that you'll need a specific functionality, but don't yet know what you'll implement in that method, you can create a temporary template of that method so that the code doesn't mark any problem. The next part deals with a concept called refactoring, which is related to the changes that you carry out in your source code. In this case, if we wanted to change the name of a method, like this one called calcular area quadrado, and rename it as calcular area quadrado 2 add the u and the alert, we immediately see two errors related to the call of this method that we had defined earlier. To correct this, we would need to put the correct name for each of these methods. We currently have a small application, which is why it was easy to correct these problems. But imagine if we had thousands of lines of code where we intensely used this method. Imagine going line by line, changing the definition of these methods. We will return the code to how it was. There's a simpler way to carry out these changes. If you go directly to your code or to the method definition, select the method name, right-click, there is an option that says Change Name. To change the name of this method, we have to start typing the new name here. In this case, calcular area cuadrado 2 pace. We can see how calls to this method are being automatically modified by Visual Studio. We click Apply, and we see that we have renamed this method easily. Lastly, as part of Visual Studio's refactoring, we can also extract code into methods. Assuming we have the definitions for these 3 lines of code again, which are readline, clear, and beep, we'll paste them into the main method. Assuming you know that you will be reusing this code over and over, you might want to put it in a method to avoid having to declare this code repeatedly. We can select the lines that you want to encapsulate as part of a new method. You can right-click and select where it says Quick Actions and Refactorings. Here we have the option to Extract Method. We click on this option. And we can see that these 3 lines are quickly encapsulated in a new method definition. We'll name this Clear Console. Click the Apply button, and we see that we now have a call to the new method called Clear Console, which encapsulates these 3 lines of code. These tips may help you in your daily C# development and are quite useful, allowing you to accomplish tasks quickly, saving you time and effort.